This is the first real lesson in conics. So you learned how to complete the square twice to graph the equation of a circle. What I'm going to be teaching you today is two different things. It has to do with a quadratic, and there's something called the focus and the directrix. And it's kind of a weird concept, so I'm going to explain it to you like this. Let's take just a super simple quadratic, and now I'm going to graph a quadratic just like this. Okay, so in a quadratic, it has a vertex. Well, there's something called a focus, and on the notes, the focus says it's a point inside the parabola. Now what happens is, if you were to draw your axis of symmetry from last year, the focus is on that axis of symmetry. It's that vertical, imaginary vertical line that goes through the vertex. The focus or foci point is on that imaginary axis of symmetry. Now, with that axis, with that focus point, the next thing is called the directrix. And on your notes, I tell you that the directrix is a line that is under the vertex. Now, it's the same, however many units of a vertical climb it is to the vertex, it's the same amount of units vertically below it. And this is the directrix. So it's equidistant. The vertex is equidistant to the focus point, and it's equidistant to the directrix line. So if I were to go up a certain amount of units here, and I were to go down to a certain amount of units here, this line segment that I've created is exactly the same line segment, top and bottom. Okay, so kind of with that concept now, if you look on the notes, the next thing that I tell you is any point on the parabola is equidistant from the focus in the directrix. And that's kind of the main theme of this. So let's take a point right here. I don't know. Let's just say right here. The distance it is to the focus point is the same distance. Obviously, this isn't drawn to scale. This is the same distance it is to the directrix line. It always has to create a 90-degree angle. And if you look on the notes that I give you another line. Let's say right here. The distance from here to here is the same distance, if this was truly drawn to scale, which this one isn't, is the same distance from here to here. So the length of this line segment is the same as this line segment, because as long as you start on a point on the parabola and you go to the focus point and you go to the directrix line, that's equal distance. So that's kind of the main theme of this. The weird thing is finding the equation of the focus, because technically, let's take another quadratic. Technically, it doesn't matter if we have a quadratic. Let's take a quadratic that's looks like this. Let's just say this is x equals y squared. It's the same thing. As a normal quadratic. So let's take a focus point. Let's say here. Here's the focus point. However many units this is technically to the right of this, because it's inside the quadratic. However many units it's here, it's the same amount of units to the left. And this is going to be this directrix line. So that's the same concept. So any point that is that's on this line is going to be the same exact, is going to be equidistant to the directrix. If you look this up online, you're going to see quadratics where the shape is like a, this is definitely not drawn to scale, but you get the point. If you look this up online, focus and directrix of a quadratic. It's kind of hard for me to teach it to you when I'm not in person, the main point is any point on a quadratic is equal distance to the directrix line and the focus point. So what I give you in the next round of directions, or not directions but words, is the equation for the focus. Now what I'm going to do is this. I'm going to take a quadratic. Let's say, I think in your worksheet they're going to try to mix it up. They're going to say 8x squared equals, I'm sorry, let's say 8y equals x squared. Let's say something like this. Okay, well, get it to be in kind of vertex form first, so you can figure out what the vertex is. So if I divide both sides by 8, I'm going to have a quadratic y equals 1/8 x squared. All right, so if I were to graph this, right here, my vertex is 0, 0. And I would go up an 8 and then over 1, up an 8 and then over 1 initially, and then I would kind of guesstimate what that quadratic is going to look like. Okay, so there's my quadratic. Now I give you an equation for the focus. I want to know where in the heck my focus is. It's inside my quadratic. That means my directrix is going to be on the bottom somewhere here. So I give you the equation, and it's going to look a little strange, but before I do this, I want to identify 3 main points, and this is what you have to do with every question that you get. I want you to identify, because remember in vertex form, technically your vertex, this is your h and this is your k, and whenever you're given an equation, the number in front of your x squared is considered your a. So what I want you to do is, when you have these, identify your h, identify your k, and identify your a. Now the equation is h comma your k plus 1 over 4a. This is the one that looks a little weird, but I promise you it's super simple. Your h is your x coordinate for your vertex. Your k is your y coordinate for your vertex plus 1/4 of 1 over 4 times your shape of your quadratic. Okay, so I'm going to plug everything in. I want to know where my vertex is, or I'm sorry, my focus point is. I know that here's my axis of symmetry. I know it's going to be on my y-axis. I just don't know how far up, because look, my h is my x coordinate, which is 0. Now I'm going to figure out my y coordinate, because this is my y coordinate for my focus. So my k is 0 plus, I'm going to rewrite this down here because I'm going to do a little math. 0 plus anything is just that number, so I don't technically need that 0. 1 over 4 times my a. The a is the shape of the quadratic, which is 1 over 8. Okay. So I'm going to 1 over, well, no, I'm sorry. 4 over 1. I'm going to cross multiply, just multiplying these two, so I'm going to get 1 and 2. So this is going to give me a fraction of 1 over 1/2, which is the same as 1 over 1 times 2 over 1, because when you're dividing fractions, it's the same as multiplying by the reciprocal. This whole thing is going to give me 2, which I'm going to plug in. I'm going to replace 1 over 4a with 2. This is my focus. If I went a little fast for you, what I did is I went 1 over 4 times a. My a is 1/8. So I knew I was going to multiply fractions, so I just changed the 4 to a 4 over 1. 4 over 1 times 1 over 8. Cross multiplied to get 1 over 1/2. 1 divided by a 1/2 is 2. This is my focus point. 0, 2, right up here. That means I'm going to have a directrix line the same distance below. So in the notes, I say, once you know your focus point, your your y coordinate, which is how many units you vertically climb from the vertex, or in English, how many units you go up, you're going to go the same amount of units down. And there's your directrix, which is y equals -2. Okay. Now that's exactly what we're going to be doing. That's it. That's how you find your focus in directrix. So the main thing that you got to do is you have to find your focus. Because once you find your focus, your directrix is the exact opposite way down. Okay, but check this out. I gave you 3 example questions. The very first question is, state the focus in directrix. Y squared equals 8x. I have to change y squared equals 8x to x equals, I'm going to divide both sides by 8 to get 1/8 y squared. Okay, now this is the weird thing. Normally it's y equals 1/8 x squared, but it's not now. It's flipped. So this is what this graph looks like. I'm going to show you an easier way to do this, but this is what this graph looks like. It's going to be a quadratic that's open left and right. Instead of up and down, it's open left or right. If it's a positive shape, it's going to be going to the right. If it's a negative shape, it's going to be going to the left. So my vertex, if you graph this, it's going to look like this. My vertex is 0, 0 because it's not there's no parentheses, not in vertex form, or it is in vertex form because there's no x or y, or h or k. Now I'm going to go to the right 1/8 and over 1, to the right 1/8 and over 1, and kind of guesstimate what my quadratics look like, something like this. This is how you graph it. I'm going to show you an easier way. I know that this is my original equation. X equals 1/8 y squared. What I'm going to do right now is I know this is what my graph is going to look like, right? So I'm just going to get rid of this, because some people, it's hard to do this because you have to think backwards. But I think it's easier if normally, this is your x-axis and this is your y-axis, right? Okay. How I would do these is this. I would take this and flip it like this. Now I flipped my graph. Now I also have to flip my x and my y numbers. So instead of x equals 1/8 y squared, I'm going to flip the x and y. I'm going to take these two and flip them to get y equals 1/8 x squared. I'm just going to flip my x and my y. I know my last step, I have to reflip everything. But watch. Now if I were to graph this, y equals 1/8 x squared, so go up 1/8 over 1, up 1/8 over 1. You can graph that super, super simple, super simple. And then you have a quadratic that's looking at you. Your answer, because I'm going to be asking you, what's your focus and directrix? Your focus, you have to flip the x into y's, because this graph is flipped, so you have to reflip it. In your directrix, you have to flip it again. I'll show you what I mean. But I'm going to treat this equation, I know it's sideways for you guys, but I'm going to treat this equation like this. I'm just going to take my x and my y and trade places to make it look like a normal graph now. Now, my vertex is 0, 0. My shape is 1/8. 1/8. Now, what you're going to see is it's the exact same equation that we did before. So pause the video and see if you can do this. This is identical to what we just did, but there's a little twist at the end. pause this video and see if you can find your focus and your directrix with this information right here. Okay, so if you paused it, maybe you worked on it for a little bit. My focus is inside here, so I know it's going to be up on here somewhere. So my focus is h, comma, and then k plus 1 over 4a. This is the equation for my focus point. My h and my k is my vertex. So h is 0. This is exactly what we just did. K is my y coordinate for my vertex, which is 0. And 0 plus anything, I don't need to technically write that 0 because it's just insinuated that there's already a 0 supposed to be there. And then remember the math that I did? 1 over 4 times a. 1 divided by 4 times my shape is 1/8. I'm going to put this as a fraction. Remember I cross canceled and I got 1 over 1/2. 1 divided by 1/2 is the same thing as 1 times reciprocal, 2 over 1, which is going to be 2. So now I'm going to graph this. 0, 2. Boop, right here. And remember this is my focus, 0, 2. It's not. This is not my answer, by the way, but I'm going to show you what I mean in a second. This is my focus. This is my directrix. So I went up 2. So remember in the notes, I say count backwards 2. Boop. Right here. Okay, now remember in the very beginning, I flipped this sideways because I converted my x and my y. I changed those. So technically, if you were to, with this is 0, 2 would be my focus. And I would have y equals, what is it? 1, 2. Y equals -2. Okay. You can either do one of two things now. So this is your answer in normal graphing. You can do one of two things. You know that your answer is flipped because I flipped my x and my y, so I have to reflip them conceptually. I have to flip this, so my focus is going to be 2, I'll just do this, 2, 0. That's my focus because I'm going to have to flip these back. And this is a y line, but I'm going to flip it, and it's going to be an x line. X equals -2. Watch this. So I'm going to return this, boop, back to its original form, and everything's already worked out for you. Look, I'm going to get rid of these because it's not y equals -2, and everything's already graphed for you. Look, here's my original graph. X equals 1/8 y squared. It's an x equal line, so it's going to be a quadratic, open to the right. This point right here, this is my focus, which is 2, 0, and this is my directrix line, which is an x line. Normally it was a y line, but when I reflipped it, I knew it was going to be an x line. X equals -2. So what I would say, because your worksheet you're going to have today, they try to trick you by switching the x and the y axis by giving you quadratics to open left and right. Treat them as regular quadratics and just reflip your paper. I would just take your paper and reflip it. Okay, let's see now if you can do the second equation. And this is, just to give you a hint, this is an equation where you're going to have to flip. X plus 1/4 y squared equals 0. Pause the video. Get this to be an x equation. You know the quadratics would be opening left or right. See if you can graph it. See if you can state your directrix and focus point. Pause the video and give it a shot, guys. All right, since hopefully most of you guys paused it, and if I were to write this as an equation, it has to be x equals, because I can't have it as y squared equals. It has to be a single to the first degree variable equals something. So it's going to be, here's my equation. X equals, I'm going to move this whole thing over by subtracting 1/4 y squared minus 1/4 y squared. 0 minus 1/4 y squared is negative 1/4 y squared. All right, so here is my quadratic. Now, some people might be saying this isn't a function because it doesn't pass the vertical line test. Yeah, that's right, but we don't care about that. All we care about is finding our focus point, which is inside the quadratic, and our directrix line, which is directly below the vertex. So if I were to graph this, just letting you know, it's going to look like this. It's going to be an x line. It's going to be a negative 1/4 y squared. So it's going to be opening down because negative x quadratics open to the left. But let's say you didn't know that. Let's just say you're like, man, what the heck am I looking at right now? Let's do this. Change this equation to flip the x into y. Just change them spot. So I'm going to say y equals negative 1, right in this sideways, 4th x squared. Y equals negative 1/4 x squared. Okay, now that I have that, watch. I'm going to flip it. I can graph this now. This is super, super simple to graph. So to graph this, what I'm going to do is I know my vertex is 0, 0, and I'm going to go down 1/4 over 1. Down 1/4 over 1. So here's my graph. Okay, now I've got to find my focus point. Identify your h and your k. My vertex is 0, 0. So my h is equal to 0, my k is equal to 0, and the other thing, your shape is equal to negative 1/4. Okay, so my focus is going to be in here, and remember the formula. Your focus is zero, 0 plus 1/4 times your a. All right? Since it's 1/4 times my a, what I'm going to do is 0 plus this is just this value. So 1/4/1 times, I'm just changing this to a fraction, times my a. My a is negative 1/4. All right, so 4 times negative 1/4 is going to be, these cancel out to give me negative 1. So it's going to be 0, negative 1, which makes sense, which is 0, negative 1 right here. That means I went down 1, I'm going to go up 1. This is going to be my directrix. So my focus is, get rid of some of this. My focus point is going to be 0, negative 1, and my directrix is going to be y equals positive 1. But the kicker is you got to flip it. Because remember, in the very, very beginning, right, our original equation was not 0, negative, or it wasn't this, it was this flipped over. So this was my original equation right here. And my focus is negative 1, 0. And my directrix line is x equals positive 1. Okay, the very last question. Very last question. If you guys want to give this a shot and try and pause it to see if you can do it, that's awesome. I'd be very impressed if you did. If you got it. It says write the so if my directrix, the equation for the directrix, it tells you in the notes, is y equals 6. That means if I go 6 up, I would have to go 1, 2, 3, 4, 5, 6 down to get my focus point. So I know my focus is going to be 0, negative 6. Now the reason why this is important is because if you remember the equation for your focus, the equation for your focus point was h, k plus 1 over 4a. I know this mess equals negative 6. I'm going to go ahead and write that. Negative 6 equals k plus 1 over 4a. I know my k is 0 because what's my vertex? 0, 0. This is your h, and this is your k. So my k is 0, so I don't need it. And here's my equation. Watch. Let's get rid of the 4a is your denominator. You're going to see why I'm solving for my a in a second. Because, well, I'll wait. I'm going to multiply both sides by 4a. This side by 4a and this side by 4a to get rid of this denominator. So I have negative 24a equals 1. Divide both sides by negative 24. Divide both sides by negative 24. And I have y equals, well, my vertex is 0, 0, so I know it's just an x squared quadratic. And check this out. My shape is equal to negative 1 over 24. Here is the equation of a quadratic if the directrix is y equals 6 and my vertex is 0, 0.